Hello again, Year 10. Today we are carrying on our topic of bearings. We are going to be using the skills of trigonometry that you were practicing last lesson, and we are going to try and embed that into our questions. The most important thing that you can do today is draw really accurate diagrams. So make sure you've got a pencil, make sure you've got a ruler, and make sure you've got your brains. So, just as a little starter activity for you today, I thought we'd have a approximation challenge. So, I have drawn A, B, C, D, E, F, G, and H all going off at different angles. Now, remember, a bearing is measured clockwise from north, and north is defined to be 0, 0, 0 degrees. So, all I would like you to do is on a piece of paper, just approximate what angle you think the following bearings are. And we'll allocate some sort of point system. If you get it exactly on, you can have 5 points. If you are within, let's say, 5 degrees, you can have 2 points. And if you are within 10 degrees, you can have 1 point. So pause the video here and have a quick guess what bearings you think each of these are on. So you can see I've just quickly uploaded a 360-degree angle measurer directly over the diagram. I'm going to tell you what these angles were, what these bearings were. And remember the point scheme, I'll let you tot it up. The point scheme was 5 points for exact, 2 points for 5 degrees out, and 1 point for 10 degrees out. So A is 0.30. B, I'm going to call that 0.75. C is closest to 112. D is closest to 126. E just a bit beyond 180. I'm going to say that's 185. F, hope you got this one exactly right. It was 270. G, I'm going to say that one is 296. And H, oh, I could go either way. It's slap bang in the middle. I'm going to say it is 313 degrees. So, how was your approximation today? So, examples that we are going to be doing today, we are going to be given some information and we are going to have to construct a diagram in order to work out some bearings. We might also be having to use a little bit of Pythagoras today to work out the distance between 2 points. So I hope you've managed to get a copy of the sheet. It's not really essential today because there isn't too much writing. So if you haven't, just put a title and objective in your book. Now, obviously I'm going to draw my diagrams freehand. You're going to be using a pencil and a ruler, so your diagrams will be a lot tidier than mine. But my top tip is try and draw your diagrams roughly to scale because that will really help in the process for you seeing what is going on today. So, example 1 says a hotel is located 3 kilometers east and 2 kilometers north of the beach. Calculate the bearing of the hotel from the beach to the nearest degree. So often when we do work with trigonometry, we might round answers to 1 decimal place. Quite often with bearings, we actually just end up rounding to the nearest degree. So what does this diagram look like? Well, we are told that a hotel is 3 kilometers east and 2 kilometers north from the beach. So imagine this blob here represents where the beach is. If I go 3 kilometers east, I'm using my compass directions, and then 2 kilometers north, So I'm going to draw that as a slightly shorter line. I'm not saying that you need to do it exactly to scale. That would represent where the hotel is. And I'm just going to finish that triangle off by joining that up with a straight line. I'm also, not very well, but I'm also going to put in some north lines at each of these two locations. Now, our question says calculate the bearing of the hotel from the beach. So it's really, really important that you've got a good understanding of which angle it is that we need. So I'm going from the beach to the hotel. So it's in this rough direction here, and clockwise from north, it is going to be that angle that I need. Now, I'm just going to approximate that. That, like in our first activity, looks like an angle, a bearing of about 060. So that's what I'm going to be looking for in terms of my answer. Now let's just populate what else we know. We said that this horizontal distance east was 3 kilometers, and this vertical distance north was 2 kilometers. And you can see I've got a right angled triangle here, and I could very easily use trigonometry to work out this angle, because this angle will help me work out the purple angle. Altogether, between north and east, that's 90 degrees. So if I can work out what angle theta is, I will be able to subtract that and work out the purple angle, the bearing that I need. And sometimes you might find today you'll be adding on to 90 degrees, you might be subtracting from 90, you might be adding on or subtracting from 180. You might be adding on or subtracting from 270. It all depends what your diagram looks like, and that is why the diagram is key. So I'm going to label some sides. The 2 kilometers is opposite my angle, and the 3 kilometers is the adjacent. You will find today, for the most part, you will be using the tan function that involves opposite and adjacent. So let's work out theta. Well, we know that tan of theta is opposite over adjacent. So tan theta is 2 over 3. We're going to need to make sure our calculator's in degrees in a moment. But if I'm working out the angle, I will need to use my inverse button. So I'm going to be using tan to the minus 1 of 2 divided by 3. Do type that in yourself. Make sure you get the same as me. But I've got that as 33.6 degrees. But since I'm going to be doing this to the nearest degree, that would round up to 34 degrees. Now do remember, that answer isn't actually my bearing. It is just the answer to the angle in the diagram. We discussed a moment ago that if I want the purple angle, the bearing, I will need to do 90 take away 34. And 90 take away 34 is 56. But we also need to remember that a bearing is a 3-digit number. So if we get an answer like 56, we're going to need to write that as 056. Incidentally, just have a look at our answer of 056. Remember I approximated it was going to be about 60 degrees? So that is another reason why I can now be confident that my answer is right. Let's have a look at another example. So in example 2, a ship sets off from port. It sails 3 miles due south and then 5 miles east. How far is the ship from the port, and on what bearing is the port from the ship to the nearest degree? So I'm going to use the information given to draw a diagram again. So I'm going to think about what this might look like. A ship sails from the port. So I'm going to put a little blob where my port is. I'll label it up later in a moment. It sails 3 miles south. And then 5 miles east. I'm going to make the 5 miles look a little bit longer than the 3. Okay. So that was where it started, at the port. This is where it's finished. So I'll put an S for ship. Now the first part of the question says, how far is the ship from the port? Well, if I label the sides of my triangle 3 miles and 5 miles, you will see that that is just a Pythagoras question. So let's quickly do that. X squared is the longest side, so it's going to be an addition. It's 3 squared plus 5 squared. So that is 9 plus 25, which is 34. So remember, if I want the distance, I will have to do the square root of 34. I will round this one to 1 decimal place. And the square root of 34 comes out as 5.8 miles. So that's the first part of the question. Second part of the question says, on what bearing is the port from the ship? So, really important, I'll put some north lines in. And we'll think about which angle it is that it's asking me to find. So it is asked, what is the bearing of the port from the ship? So I'm starting at the ship, so I need to go clockwise around my north line. So that is all the way around and in that direction. So that is beyond 270 and a little bit more. So maybe about 300. And that also has given me a clue as to how I'm going to work this out. I know all the way round to west, that line there is 270. And then if I work out this angle here using the triangle and trigonometry, I will be able to add that one on to 270 degrees. So let's try working out angle theta. So tan theta is opposite, which is 3, divided by adjacent, which is 5. So theta is tan to the minus 1 of 3/5. Do that on my calculator. Again, if you'd like to check, we get an answer of 31 degrees. But remember, once again, that is not my bearing. I need to add it on to 270. So the bearing is 270 plus 31, which is 301 degrees. So once again, my little approximate guess of 300 makes me confident I've got my answer right. Now, there are some questions for you to try. I'm not sure you'll be able to get all of them done, but just give it your best effort. If you go back to my instructions, you'll be able to get a link to a bigger version of this document. I would write the questions out or print them out if you prefer. As always, check your answers at the end of the lesson. Use a different coloured pen. And if you've got any questions, you can ask in the Ask the Teacher channel.